Here we have the male reproductive system. The testes are the gamete-producing organs of the male. They produce sperm and testosterone. They are held outside the body in a sac known as the scrotum. It is made out of skin, connective tissue, and smooth muscle called dartos muscle. The cremaster muscle runs along the spermatic cord, which is here. It helps elevate the testes closer to the abdomen to adjust temperature for sperm production. The epididymis consists of a head, body, and tail. It is responsible for sperm maturation and acts as a storage site. The spermatic cord consists of the ductus deferens, the testicular artery, and the pampiform plexus. The ductus deferens is a tube that carries sperm down to the ejaculatory duct, which is found right here. The ejaculatory duct connects with the prostate gland. Some accessory glands of the male reproductive system. The seminal vesicle produces seminal fluid. It attaches to the ejaculatory duct near the prostate gland. The prostate gland produces prostatic fluid, which is alkaline. The bulbourethral gland produces alkaline mucus prior to ejaculation that cleans out the urethra. The penis consists of a root, body, and glands, the enlarged end of the penis. The prepuce is the skin that covers over the glands. The corpus cavernosa is located here in purple. The corpus spongiosum is located around the urethra. When blood fills these, it results in an erection. We begin spermatogenesis with our spermatogonia, or our stem cell. Through mitosis, our spermatogonia divides into a type A daughter cell, which stays against our basal lamina, and our type B daughter cell, which from here continues to grow until it enters meiosis 1. As a result, we get primary spermatocyte. Our primary spermatocyte continues through meiosis until it is completed and gives us 2 secondary spermatocytes. Our secondary spermatocytes go through meiosis 2 to give us 4 spermatids.
After meiosis 2, we enter late spermatogenesis. A spermatid is going to continue to grow. It's going to elongate. Here we now see mitochondria, acrosomal vesicle, the nucleus, and a very small tail. As it continues to develop, it's going to shed its exocytoplasm and form a tail. The mitochondria, it's going to begin to form the midpiece. It'll detach from the systemicular cell and become a fully mature spermatozoa, ready for fertilization.
Here we have spermatozoa. Structures include the head, which contains DNA in the nucleus. The acrosome contains enzymes necessary to get through the corona radiata and the zona pellucida. Moving on to the midpiece, or neck, contains mitochondria and contractile fibers that act as the engine that propels our spermatozoa. The tail, or otherwise known as flagellum, can otherwise be known as the plasma membrane of our spermatozoa.
Here we have the female reproductive system, suspended by broad ligaments in the peritoneal cavity. Here we have an ovary. The outermost layer of the ovary is the terminal epithelium. The tunica albuginea is the fibrous tissue that surrounds the ovary. Here we have the uterus. It has three membranes. The peritoneum is the outermost. The myometrium, which is smooth muscle that contracts to eject the baby. The inner lining is the endometrium, which has two linings, the stratum basalis and the stratum functionalis. The stratum functionalis is the one that sheds every month. Here we have the vagina, which is the internal tube. We have the posterior and anterior fornix. We have the cervix, the internal and external os. The vagina has the rugae, which allows for stretching. And the functions of the vagina is to create a passageway for the baby, menstrual flow, and for female copulation. The external genitalia, also known as the vulva. Here we have the mons pubis, which is a fat pad that covers the pubic symphysis. The labia majora, similar to the scrotum. Labia minora, that covers the vestibule. Here we have the clitoris. And here we have the greater vestibular glands that produce lubricant to facilitate intercourse. Here we have the mammary glands, superficial structures, the nipple, the areola, have the lobules, electiferous duct, lactiferous sinus, which leads to the nipple and ejects the milk. One hormone that targets the breast is oxytocin, which leads to milk letdown.
Our ovarian cycle starts with the monthly release of an egg. Our follicular phase starts day 1. When FSH is added to our primordial follicle, it grows into a primary follicle. Its follicular cells turn into granulosa cells, which secrete estrogen and target the pituitary gland to inhibit LH. We start to form a zona pellucida, which is going to be used to prevent polyspermy. And this primary follicle continues to grow until it turns into a secondary follicle.
The secondary follicle is going to develop pools of follicular fluid, and it's going to grow into an antrum. At this point, we have a mature follicle. It's going to go through meiosis 1, and we get a secondary oocyte plus the first polar body, which is excess DNA. Around day 14, we get ovulation. The follicle is going to rupture the ovary. And we have now a corona radiata, which provides nutrients and support for the oocyte. The remaining follicular cells are going to turn into a corpus luteum by the hormone LH, and it's going to continue to degenerate until it forms a scar called the corpus albicans. Hormonal effects on the ovarian cycle. GnRH is going to target the anterior pituitary gland, and it's going to stimulate the release of FSH and LH. These hormones target the follicle. It causes it to grow and mature. The follicle, when it grows, the granulosa cells are going to release estrogen. It's going to cause a negative feedback on the anterior pituitary gland. It's going to tell it to hold on to LH. FSH and LH cause meiosis, and we get a secondary oocyte in a first polar body, which is excess DNA. LH will trigger ovulation. Estrogen levels will drop, resulting in the corpus luteum. Corpus luteum is going to start to release progesterone and estrogen. These two hormones inhibit the release of FSH and LH, preventing the formation of new follicles. If there is no fertilization, the levels of LH are going to decrease. The corpus luteum will degenerate, which will result in progesterone and estrogen levels to drop. That's going to trigger the release of FSH and LH from the anterior pituitary gland, starting the whole cycle all over. If fertilization occurs, then the embryo will implant into the uterus. It's going to release the hormone HCG to maintain the corpus luteum. This is a baby's way of saying that it's here. Here we have the menstrual cycle. It usually lasts about 28 days. Day 1 through 5 is the menstrual phase. Here, the uterus is going to start to shed the stratum functionalis through menstrual flow. The follicular phase. Estrogen levels start to rise, and the stratum functionalis starts to regrow again. Day 14 is usually the ovulation phase. The egg is going to rupture the ovary and make its way down to the uterus. The luteal phase. The egg has reached the uterus and it's going to be ready for implantation. Estrogen levels start to decrease as well as the LH levels. It's going to trigger the release of GnRH hormone, and that's going to trigger the release of FSH and LH hormone, and those two hormones are going to let the whole cycle start all over. Thanks for watching. Today we talked about the female and male reproductive system.
I hope you enjoyed this video and please subscribe to Mr. B's Anatomy.